Okay, you're welcome back to Introductory Mathematical Analysis B. And now we are in 12.4. We are now in 12.4, which is implicit differentiation. Implicit differentiation. Alright, we are used to when you are given y equals to something, maybe x squared plus x plus 1. That means you are given the value of y explicitly. That means after the equal sign, which is the left hand side, we have only x there. So you are given y in terms of x. Okay. Now to derive this, you derive and say y derivative is 2x plus 1. Okay. So you can just derive like that. Okay, but sometimes the equation given to us is not explicit. So for example, you have an equation like this. For example, you have an equation like this, xy squared equals to y plus x squared plus y. Okay, something like this. Now, here you cannot get y explicitly. So if I want to factorize y now, and I bring everything together that has y, I'm going to be having something like this. And then I will have y into xy minus 2, okay, equals to x squared. Now, my y will still be x squared minus 2. So you see, here at the left hand side, we cannot do away without y. Y is still there. So when you have such an equation like this, and you want to derive, we use what we call implicit differentiation to do such. Okay, all right. So implicit differentiation is a technique for differentiating functions that are not given in the form y equals to f of x or x equals to f of y. Okay, so if you are not given in this form, we use implicit differentiation to do such derivatives. Okay, all right. So with that understanding now, let's now go into what we mean by implicit differentiation and how do we do it. Okay, I will start from what you know. You know y equals to x squared plus x. Okay, how do we derive this? Y prime equals to 2x plus 1. That is how to derive that. Okay, that is the derivative. This derivative can also be written as dy over dx equals to 2x plus 1. You can also write this like this. Okay, that is the derivative. So you just say the derivative is 2x plus 1 by using the power rule. Okay, that is fine. But look at it this way. We have y equals to x squared plus x. Now, I will just derive y as if it's x. So if I derive this y, it's 1. Okay, as if it is x. But because I'm deriving y, I'm going to have multiply by dy equals to, I derive x, 2x, then multiply by the x, plus derive another x, 1, multiply by the x. Alright, so if I say 1, I don't need to write the 1 again, so I just say dy equals to 2x plus 1 into the x. Am I right? So I can now divide both sides by the x. So it becomes dy over the x equals to 2x plus 1. You see, I've gotten the same thing as I have here, as I have there. Okay, so now the idea of implicit differentiation is now this. Okay, so I have the same thing now. Now, because y is a function of x, anytime I derive y, I'm going to multiply by dy over dx. Anytime I derive anytime I derive y, I'm going to be multiplying by dy over dx, because y is a function of x. If x is a function of y, then I'm going to be multiplying by the x over the y. Okay, so but now here y is a function of x, so I'm going to be multiplying anytime I derive y by this, because y is a function of x. If x is a function of y, then anytime I derive x, I'm going to be multiplying by the x over the y. Okay, please take note of that. Now let's see. So I'm going to derive this with that understanding. So I'm deriving y now. If I derive this, is 1. But don't forget y is a function of x, so I multiply by dy over dx. I derive this 2x, I'm not multiplying by anything, plus I derive this 1. Okay, you can see this is now dy over dx equals to 2x plus 1, just like we got before. Okay, so that is the idea of implicit differentiation. That is very important. Please take note of that. Ensure that you understand. Then let's take an example. So find dy over the x by implicit differentiation if y plus y3 minus x equals to 7. Okay, don't forget that you don't need to make y the subject of anything. Just derive the way it is. Okay, so let's go to the next page. So we want to find what is given to us is this one. We want to find the y over the x. Okay, so let's derive. Just derive y as if you are deriving x. Okay, so now we derive this, that is 1. But because y is a function of x, we multiply by dy over dx. Plus, derive this 3y squared. Because y also is a function of x, we multiply by dy over dx. Minus derive this 1. Derive this 0. Okay, so what we need to now do is to make dy over dx the subject. Okay, so we bring it together, so it will be dy over the x 1 plus 3. So you factorize dy over the x out there and bring this one to this side. Okay, so you bring this one to this side and then you factorize dy over the x out. So dy over the x we are looking for is 1 over 1 plus 3. Okay, that is the derivative. All right, please take note of that. Do a second example. find the y over the x if s3 plus 4xy squared minus 27 equals to y4. Okay, so this is very important. Please ensure that you understand. Now we have something here. We have x multiplied by y, and don't forget we are deriving both of them, and because of that, that makes a product rule. A product rule. A product rule. Okay, so let's derive now. Derive this, it will be 3s squared. We are not multiplying by anything because y is a function of x. Plus, now to derive this is a product rule. Hold on to x, derive y, hold on to y, derive x. That's what we're going to do. But I pull out this constant first. So I'm holding on to x, I'm deriving y, multiplied by 2y. But because this is y, which is a function of x, I need to multiply by the y over the x. Plus, that is product rule. Hold on to y, then derive x multiplied by 1. Okay. Now, derive this minus 0. Derive this 4y3, but because this is also y, a function of x, we need to multiply by the y over the x. Okay. All right, so let's go. Let's tidy up. So 3s squared plus this becomes 8xy dy over the x plus 4y squared. Okay, this minus 0 goes away. This is 4y3 dy over the x. Okay, so we bring everyone with dy over the x together. Okay, and bring every other one to the other side. So 8sy dy over the x minus 4y3 dy over the x equals to negative 3s squared negative 4y squared. Okay. Alright, so we need to make dy over the x, factorize dy over the x to give us 8xy minus 3 minus 3s squared minus 4y squared. Now the y over the x is now negative 3s squared minus 4y squared all over y minus 4. Alright, that is the answer. So in implicit differentiation, you derive them the way they are, then you factorize out the y over the x and make the y over the x the subject. Okay, that is when y is a function of x. When y is a function of x. But that means when x is a function of y, we are not going to be multiplying by the y over the x, but we are going to be multiplying by the x over the y. Okay, so I take this example now and do it as a function of x. Okay, we have this now. This is another example, another example. So here we are giving the same, I'm taking the same. So I want you to find the x over the y. So that means x is a function of y. X is a function of y. So let's do this one. X is a function of y. Okay, how do we do this? That shows that every time I derive x, I need to multiply by the x over the y. Okay, so I derive this now, it will become 3s squared. But because x is a function of y, I need to multiply by the x over the y. Plus, okay, this one again, I pull my 4 out, it's also a product rule. I hold on to x, I derive y, multiply by 2y. I'm not multiplying by the x over the y because I'm deriving y, not x. Plus, I hold on to y, I derive x, multiply by 1, but because I'm deriving x, I need to multiply by the x over what? Over the y. Alright, so now I derive 27, that is 0. I derive y, 4y3. I'm not multiplying it by anything because y is not the function of x. Okay, please take note of that. Now I open up this 3x squared, the x over the y, plus 8xy plus 4y squared, the x over the y, equals to 4y3. Alright? Then I bring the one that has the x over the y together, plus 4y squared, the x over the y, equals to 4y3 minus 8xy. Now the x over the y into 3x squared plus 4y squared. Okay, equals to 4y3 minus 8xy. Alright, so making our the x over the y the subject, then we have 4y3 minus 8xy all over 3x squared plus 4y squared. Okay, you see, that is it. This is when we are looking for the x over the y. That means x is a function of y. But here you see we are looking for dy over the x, which is y is a function of x. You see, we have two different answers. What we have at the denominator now is now the numerator here. Okay, and then the sign also changes. Please make sure that you understand. Ensure that you understand.